Good morning. Today on You Can Do It Math, we're going to do the May-June 2021 paper 21 extended. This is going to be fun. Question 1, symmetry. Rotational symmetry and lines of symmetry is not the same thing. Rotational symmetry is when you trace it, ask for tracing paper in the exam. If you don't have any, they have to give it to you. Trace the shape. Mark the top left hand corner, and it's how many times the shape fits onto itself when we rotate it. Meaning, okay, start rotating. Fits once, twice, three, and back where we started. That's 4. So we got a rotational symmetry of 4. Lines of symmetry is when you draw lines. So always use a ruler and a pencil. It is symmetrical lines. The most obvious ones is the horizontal line of symmetry and the vertical line of symmetry. So we got the mirror image there. But in this case, since this is a square and all 4 corners are shaded the same, there are 2 diagonal lines of symmetry. So in this case, there is also 4 lines of symmetry. Question 2. The probability that a train is late is 0.15 or 15%. Write down the probability that the train is not late. So all probabilities always add up to 100% or to 1. So it means we just need to find the other side of that 15%. So 1 minus 0.15 or 100% minus 15% gives me 0.85 or 85%. Question 3, stem and leaf diagrams. Okay, this one shows 16 students who studied last week. First of all, the median. The median, of course, the middle. Using maths to work this out, we do 16 plus 1 divided by 2, which will give us 8.5. That's not the answer, 8.5. That shows us where is the middle if you had 16 students. The middle will be between the 8th and the 9th student. So all we need to do in the stem and leaf diagram now is count the values. We got 1, 2, 3, 4, 5, 6, 7, 8. So there's the 8. The middle is between that 7 and that 9, or rather 27 and 29. Okay, always do count the other side as well. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's the middle. We got 8 smaller. We got 8 bigger. So what's halfway between 27 and 29? Of course, it's 28. Okay, 28 hours is the median amount of time studied by 16 students. Right, the mode, the most. Which number occurs the most? We look over here, there's only one space where there's 2 numbers next to each other, and these 2 1. So the answer is not 1, but of course 21 hours. Okay, and then the range, biggest value, which is the last one, 47, minus the smallest value, the first one, 12, gives us 35 hours. Question 4 shows us 2 parallel lines. Immediately start looking for those corresponding angles or F angles or the alternate angles or the interior angles. All right, parallel lines, think about those immediately. All right, and then let's look. Question A. This is not part of the parallel lines. We got here opposite angles, straight opposite. So that's easy. That's 59 degrees. Okay, then question B. Yes, here we've got corresponding angles. If you look here, there's the upside down F shape. So it means 37 and angle B is the same. Straightforward, 37 degrees. Question C then, we can do angles in a triangle. as follows. Okay, or you can do angles on a straight line and do corresponding angles, but since we got 59 here and 37 there, we do 180 minus the other two angles in the triangle, and that gives us 84 degrees. Question 5, column vectors. It's straightforward doing these questions. For the first two, just remember, this is not fractions. Don't confuse with fractions. Column vectors, you just add them together. 6 plus 8 is 14. Minus 5 plus minus 1 is minus 5. Minus 1 is minus 6. Let me show you what we're actually doing here. Okay. So a column vector of 6 minus 5 means we start at one point and we move 6 spaces, units to the right, and the minus 5 means we're moving 5 units down. So that gives us that vector there. All right, going that direction. Then we have the next vector moving on from there, 8 minus 1, which means we're moving 8 units to the right because it's positive, and 1 unit down because that's negative. That gives us another vector. Now when we add these together, what we're doing is we're making this one big vector like that. And this vector, to get from the beginning to the end, we are moving 14 spaces or units to the right and 6 spaces down. That's why we can just add them together. That's question 5a. Question 5b, we got the scalar in front there, the 3. We simply multiply it with both numbers in the column vector. That's 3 times minus 4 is minus 12. And 3 times 7 is 21. Why is this correct? Let's have a look at that. Okay, a vector of a vector of minus 4, 7 means that we're going to start at the bottom here. We're moving 4 spaces to the left, and then we're moving 7 spaces up. 1, 2, 3, 4, 5, 6, 7. And that is what will give us this new vector going in that direction. So that is the vector once only, okay, with an arrow. Now the 3 in front means we just triple that vector, so we keep moving in that direction. So it means we go another 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. Now I've doubled the vector, and another 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There we go. And that means we have now tripled the vector. Okay, put an arrow in there. Okay, so in the end, what that means is instead of moving 4 spaces to the left, we have now moved 4, 8, 12 spaces to the left, minus 12, and instead of moving 7 spaces up, we now move 7, 14, 21. That's how you triple a vector. Question 6a, sequences. It should give us the nth term rule of the sequence n squared plus 3n, and we define the first 3 terms. Straightforward. So term 1, we substitute 1 into the n, so it will be 1 squared plus 3 times 1, which of course is 4. To find the second term, we substitute the 2 in there, so it's 2 squares plus 3 times 2, that's 6, plus 4 is 10. And to find term 3, we substitute a 3 in there, so 3 squared, 3 times 3, that's 9, plus 9 is 18. Okay, next one, the opposite way. We need to find the nth term rules. The first thing we do is we look at the common difference between the sequences, the term to term rule. And here is we are subtracting 7 each time. Okay, that does not mean my nth term rule is n minus 7. Never. Okay, it means we've got something similar to this negative 7 times table. That means our terms start with a negative 7n. Okay, now the negative 7 times table looks like this. Minus 7, minus 14, minus 21, minus 28. Okay, what we have here is 25, 18, 11, 4, etc. So we're going to see how do we get from 25, or rather from minus 7 to 25, or from minus 14 to 18. Okay, and the answer here is we need to add 32. Each single time you add 32. To get from minus 28 to 4, you need to add 32. Maybe an easier way to find that plus 32 is continue the sequence in the opposite direction. So if we go the opposite direction, we need to add 7 each time, add 7 here, we get 32. Call that the 0th term. That is usually what gets added to the end. Question 7, simultaneous equations. They've lined up the x term nicely, the y terms nicely, and the equal signs nicely. So the most popular way to do this is by elimination. You can do substitution. We're going to do elimination. I'm going to show you 2 ways to do that. First method, I think is going to be my favorite, is I'm going to multiply the first equation by 5, which gives us 10x plus 5y equals 15. Write the second equation again, just underneath that. Right, now we need to ask ourselves, are we going to add or subtract these 2 equations? All right, let's see. If we're going to subtract them, we'll get 5y minus 5y. 2 minuses makes a plus, so it'll be 5y plus 5y, which gives us 10y, which is not what we want. We want to eliminate that y term. So subtracting is not going to work. We're going to have to add it. Because 5y plus minus 5y, plus and a minus is a minus, so it's 5y minus 5y, eliminates the y, it's gone. So adding will work. So we do 10x plus 1x gives me 11x. 15 plus 40 is 55. It looks sweet because now if we divide 55 by 11, we get the x value, which is 5. Right, once we got the x value, substitute it into any of the equations at the above to give us the y value. Which one will we do? Let's do the first one. Right, so 2 times 5 plus y equals 3. That gives me 10 plus y equals 3. Subtract the 10 from the 3, gives us negative 7. Okay, got the answer. Let's have a quick check. Is this correct? Let's use the second equation, see if it works. Substitute the x, the 5 for the x in the second equation, minus, we got 5, substitute the y in there, minus 7. Okay, should equal 40. So 5 minus 5 times minus 7, 2 negatives is a positive, 35. 5 plus 35 is 40. Yes, it's correct. We got it right. Question 7. Another way to do the elimination method is to get the x terms, the number in front, the same. So in that case, we will multiply the second equation by 2, which will give us 2x minus 10y equals 80. Let's write the first term again. Okay, now what are we going to do? Add or subtract? Let's see. If we subtract, we get 2x minus 2x. That eliminates the x's. That's what I want. So we're subtracting. Okay, y, 2 negatives, minus 10y makes a positive. So it's actually y plus 10y, which gives us 11y. And then we have 3 minus 80, which gives us negative 77. Is that right? My goodness. See, that's why I don't prefer this method. I hate working with negative numbers. Anyway, so we do minus 77 divided by 11. Okay, which gives us the y value -7. Right. Now, substitute that into one of the equations above to get the x value. I'm going to pick the first one, so 2x plus, and instead of y, I put the -7. Right. Let's add 7 to both sides. So that will give us 2x equals 10. Divide the 2, x equals 5. Okay, now we have the right answer again. Question 8. Without using a calculator, work out 1 3/8 minus 5/6. You must show you're working and give your answers a fraction in its simplest form. Right, not using a calculator means we can't do this. We can't press the fraction button, put 3/8 minus 5/6, press equal, and write down the answer. Okay, that won't get us any marks. Okay, they want to see the working out. Meaning, first thing we need to do is change the mixed fraction to an improper fraction. Meaning we do 1 plus 8 is 8 plus 3 is 11/8. If ever in the exam you get confused, you can just do it on your calculator. It does it for you. Nobody's going to check. Okay, next step is getting a common denominator for 8 and 6. 8 times 6 is 48. That would work, but a lower value here is 24. The lowest common multiple, of course, meaning we multiply the 8 by 3. So we do with the 11. 11 times 3 is 33. We multiply the 6 by 4. So we do the 5. 5 times 4 is 20. And that's it. 33/24 minus 20/24 gives us our final answer, 13/24. Now that we have shown all the working, we can get full marks. We get a mark for changing the mixed fraction to improper fraction. We get a mark for getting a common denominator. And only after we got those 2 marks, we'll get a mark for our final answer. Question 9a. Coordinates. Okay, they want us to find the midpoint between those 2 points. Let's see what it looks like on a grid. Right, we've got 2 points there. This one down here is A, and up there we got point B. And if we were to connect them with the line like this, we need to find the midpoint, which is there. So we can see the answer straight away here. It's going to be -7 minus 1. But how to do it without a grid? Well, first we need to take this change in x, which goes from 5 to 9, and find the middle. Okay, and to do that without a grid, we label this x1, x2. We need to add those 2 values together, which will give us 5 plus 9, which is 14, and then divided by 2, that will give us the middle point, which is 7, which we can see over here. It's 7. Then for the x value, we need to take this distance here, which goes from -5 up to 3, and find the middle value there. So we do the same as we did before, make that y1 and y2, add them together. So in this case, it's -5 plus 3. -5 plus 3 is, what's that, -2. And then half it because we want the middle. -2 divided by 2 is -1. And we know it's right because that is what will give us this point here, which is 7 minus 1. Okay. Right. For B, find the length. Again, looking at our grid here. Okay, this is a simple Pythagoras question. We need to take the length of this side, which we can see is 4 squares, and the length of that side, which is 8 squared, and then find the hypotenuse. That is why our formula for finding the length of a line is simply Pythagoras. Okay, which is square root to find the length on the x value. In this case, we need to subtract the two x values. Oh, made that a bit of a mess. Subtract the two x values, which is going to give us, what is that, 9 minus 5, which we wanted, which is 4, of course. Don't forget to square. Then adding to that the distance between the two y values, so that is y2 minus y1 squared for Pythagoras. So in this case, it will be 3. And this is where a lot of mistakes come in. We're subtracting, but the y1 value is negative 5. Okay, two negatives makes a positive, which means we're adding. So 9 minus 5 is 4 squared plus 8 squared. Put that into our calculator. Square root 4 squared plus 8 squared. And we get the answer. 8.9442, etc. Rounded to three significant figures. 8.94. Question 10. Transformations. Very exciting. First one asks us to describe fully the transformation of triangle A onto B. Now, it's not changing size, so it's not enlargement. It's not symmetrical, so it's not a reflection. It doesn't stay in the same orientation. It's not a translation, so the only thing it can be is a rotation. So that's the first thing you want to write to get your first mark. You write there rotation. 1 out of 3 marks. Okay, next thing is, of course, finding the center of rotation. Now, quickest way probably here is just trial and error. You rotate it, you say, okay, I'm a bit too low, a bit too much to the left. Let's go up a bit. Okay, now I'm a bit too high, a bit too much to the left still. So let's try something to the right, and bang, before you know it, you have it. Okay, so there it is. Our center of rotation is right there. So we can write here center of rotation, but just center is fine. Along the corridor is 0. Down the stairs, -1. Okay, that's another mark. And we're also going now for the angle and direction. So this is a 90-degree turn, a quarter turn. Okay, if you're not sure, you can always connect one of the corners with a line. Let's connect that same corner with a line there. You can see there, 90-degree turn, and the direction is anti-clockwise. Right, question A, part 2, the transformation from triangle A to C. Okay, and here it clearly changes size. Whenever it changes size, it's an enlargement. That gives us a first out of 3 marks. Okay, then we look at the change in size. Now it's gotten smaller. That is not a negative scale factor. That is a fractional scale factor. If we look how wide this triangle is, the 3 squares is now reduced to 1 square. So you could say it's been divided by 3, or rather the scale factor is 1/3, because the new shape is a third of what it was before. That is the 2 out of 3 marks. To get full marks, we need to find the center of enlargement. Okay, to do that, we connect the corners. First, we got the top corner there. Draw a nice clear line. Bottom right-hand corner. Okay, make sure you do this very accurately. And we can then see where they cross, but just to make double sure, let's do the right angle, connect those, and if you do it right, they should all converge in one spot, which gives us our center of enlargement over there, which is 6, 6. So again, we can just write center 6, 6, and I get my third mark. Right. Then the last question here, question 10b, draw the image of a triangle after a translation by vector 2 over 10. Remember vectors, the top number tells us how much we go left or right. If it's positive, we go right. The bottom number tells us up or down. If it's positive, we go up. So 2 squares to the right and 10 squares up. Safest way is just to use your tracing paper. And let's go. 2 squares to the right. 1, 2, 10 squares up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's mark our corners there. Make sure the shape stays exactly the same size, same dimensions, just in a different spot on the paper. With the ruler and a pencil, and now we have full marks. Question 11a, indices. Right, now we've got all of this in the brackets, 4ab to the power of 5 to the power of 4. So remember, that means everything is to the power of 4. We got 4 to the power of 4, a to the power of 4, and b to the power of 5 to the power of 4, which means we need to multiply these indices. Right, so what they want you to write these answers in numerical form. So it means 4 to the power of 4, we have to write the actual value, which is 256. Got the a to the power of 4 and then b to the power of 20. Question B, find the value of p. First thing we'll do here is we will get rid of that 2, so we divide both sides by 2, which gives us p to the power of the third equals 3. Now, p to the power of third, if you remember your laws of indices, is the same as the cube root of p. Let's just write that decently. Cube root of p equals 3. So how do we get rid of that cube root? We cube it. Okay, which means if we cube here, we cube the other side, that gives us p equals 9. Of course, you can double check if your answer is correct by putting the 9 where the p is. So it's 2 bracket 9 close bracket to the power of fraction 1 over 3. And that is not right. We didn't get the right answer. Yes, because 3 cubed is not 9, of course. It's 27. You see, that's why you check your answers, so you don't lose marks making silly mistakes. Okay. Yeah, like I've just done. So let's correct that. The answer is not 9, 27. Yes. All right. Next question. 11c. Find the value of t. Okay. Now the best thing here is to get all the base numbers the same. All right. What does that mean? It means, first of all, I can write 9, of course, as 3 squared. But if I get 81, the base number 3, what would that be? So let's think. 81 equals 3 to the power of what? And if you can't get it straight in your head, you do some trial and error. We know it's not cubed, so let's try 3 to the power of 4. That's it, 3 to the power of 4. So 81 is 3 to the power of 4. But be careful, there's already a square. So what we're actually doing, we're writing 81 is 3 to the power of 4, but that still needs to be squared. And we've got a power to a power, just like in question A, we need to multiply them together. So that means we've got 3 to the power of 8 divided by 3 to the power of t equals 3 squared. Now, when we're dividing with indices, we need to subtract. That means, okay, to get this 2 here, we should have done 8 minus t equals 2. So what do you subtract from 8 to make it 2? The answer, of course, is 6. Okay, once again, we can check if this is correct by substituting the t in there. So let's type the original question into our calculators. 81 squared divided by 3 to the power of 6. That equals 9. And we know we got it right the first time this time. Question 12. The profit of a company decreases exponentially at the rate of 0.9% per year. All right, this immediately reminds me of compound interest, which, if you remember, that's the formula, compound interest, where we take the principal amount, the original amount, we do 1 plus the rate, the percentage of interest, to the power, which is the number of years. Only difference now here is it's not compound increase in interest, it's decreasing. So we kind of have the same formula, but because we are decreasing, we put a minus where the plus is, because the value is going down exponentially. Okay, so our formula is going to look like this. Take the principal amount, in this case is 9,500. 1 minus the rate is 0.9 over 100, close the bracket, and the time from 2014 to 19, of course, is 5 years. So let's put that into our calculator. 9500 bracket 1 minus fraction 0.9 over 100. Use the side arrow bracket to the power of 5, and there we get an answer, 9,080.12, etc. 3 significant figures is 9,080. Think, does this make sense? Yes, the amount is less, not by too much. 0.9% is not too much, and we know we got the right answer. Question 13. According to the examiner's report, this was the question that the most candidates got wrong, right? The least successful question on the paper. So let's look very carefully at what we're going to do here. Right, we got a map scale of 1 to 24,000. Now remember, there's no units. That means that anything that is 1 centimeters, 1 unit on the map, like 1 centimeter, is 24,000 in real life. So 1 centimeter is 24,000 centimeters in real life. This is a linear scale factor. Okay, but we are not going to use the linear scale factor. We need to work with area. That means the ratio needs to be square. So if I got 1 centimeter square on the map, then the actual amount in real life will not be 24,000. It will be 24,000 squared, which will give us 24 centimeters squared. Okay, since linear and area scale factors are not the same thing, they change. Now we can put that into our calculator. It's going to give us a massive amount, 576 million. Okay, let's leave it there. Next thing we need to know is that we don't have 1 centimeter square, we've got 32 centimeters square, meaning we need to multiply this ratio by 32 on both sides. So that is my actual amount. I need to now multiply that by 32, and yes, it gives us quite a big number. In fact, too big to fit on my computer screen. That's why the calculator is giving it to me in standard form, which is fine, because we know how to use standard form, don't we? So let's write that down. Okay, we're almost there, but answer in kilometers square, ours is in centimeters square. So let's write this down. 1.8432 times 10 to the power of 10. Now again, if this was centimeters and we wanted to change it to kilometers, we would have had to divide this by what? Let's think quickly. Right? To change from centimeters to meters, we need to divide by 100. And to go from meters to kilometers, we need to divide by 1,000. So linear, we need to divide it by 100,000 when we change from centimeter to kilometers. But now, since we are doing centimeter square to kilometer square, we also need to square that amount we divided by. So we're going to take this value, still have it on my calculator, and divide it by 100,000 squared. And that gives us an answer of 1. Let's write it here, 1.8432. Okay, now I don't know why on the mark scheme they say that is the only correct answer. I'm sure if you write the full answer and then round it to 3 significant figures, they got no reason not to give you your full marks. Question 14. Y is directly proportional to the square root of x minus 3. Let's put that in mathematical language. Y is proportional to the square root of x minus 3. Okay, now if you want to change that proportion sign for an equal, we need to put in k, the constant. That is the constant amount. We need to multiply it to keep the proportion the same. Now that we've got an equation, which is your first mark, we can substitute these x and y values in there to work out what is k, our constant. So y is 20, x is 28 minus 3. 28 minus 3 is 25. Square root of 25, of course, is 5. Divide the 5, we have the value of k, which is 4. Bam, we got another mark. Okay, now we're going to take this equation, we write it again, but now we got the value for k, so we put that in there. And that is our equation, our formula. We can now work out any x or y value for this proportion. In this case, they want us to work out x equals 39. So 39 minus 3, of course, is 36. Square root of 36 is 6. We multiply it with that 4 in front, which will give us the final answer, 24. Question 15. Make h the subject of this formula. Right, now I know first thing students always tell me, there is 2 h's, what do I do now? Okay, don't panic. No, you can do this. Just start by doing what you know how to do. We know how to expand brackets, so let's do that. Let's expand those brackets. G times 1 is G. G times minus h is GH. Bam, you really got 1 mark. Okay, next thing, we know to change the subject, make it h. Look down here, we need to get the h by itself on the one side of the equal sign. So let's do that. Let's take all the h's we have, put them there. So I got my 2mh here on the left hand side of the equal. I'm going to leave it there, and I'm going to take this term and move it to the other side. The negative becomes a positive. Okay, so I'm moving in the right direction now because I got all my h's on one side. There's still stuff there I need to get rid of, but we're moving forward. We're getting marks. Okay, next step is to make those 2 h's 1 h, and the only way to do that is by factorizing. So factorizing out, it means we put the h in front of the bracket. Inside the bracket, we put the 2 terms without the h. You see, this is still the same because if we multiplied out these brackets, we get what we have above there. Okay, now we're almost there. We're almost done. We just need to move this 2m plus g, get it to the other side. Remember, this means h times the whole bracket. So what we're going to do is we're going to divide it on the other side. And before you know it, you've done it. You've got the answer. That is it. G over 2m plus g. Okay, it's always good to stay hopeful here, because you get marks for every step along the way. Lots of marks you get picked up there. Question 16, linear graphs. Right, first find the gradient. Now remember, the gradient is always the change in y over the change in x. How much the rise over the run. All right, so what we need to do here is we need to draw a right angle triangle to figure it out. Now, never start your right angle triangle in the middle of nowhere. See, that's not a whole square there. That's not going to work. We need to pick a spot where the lines and the squares intersect so I can count whole squares. So going to the side there and then going up anywhere else, I can't complete whole squares until I get here. Now I can clearly see I was moving 4 squares to the left and 3 squares up. Okay, what does this mean? Okay, the rise is 3 over the run is 4. One more thing here. We move to the left down here, which we move towards the negative. So it's -4. Where the line is going down, it's got a negative gradient. So it's -3 over 4. Right, you can put that minus above, below, in front, same thing. Okay, now finding the equation of the line. Okay, remember the basics here, that the m is the gradient. So immediately we got -3 over 4x, and the c value is where we cross the y-axis, which is at 2. Question 16c asks us to find the equation of a line that is perpendicular to our line up here. So let's draw a perpendicular line. Okay, it's not going to be in the right place, but we're just drawing to see what happens to the gradient. So if we got a perpendicular line there, which means now we got a 90-degree angle, let's see what's happened to the gradient. Okay, so we make our right angle triangle here. Okay, remember the previous line had a negative gradient of 3 over 4. First thing we notice is we now have a positive gradient, and our run is 3 and our rise is 4. Okay, being the run over the rise, the change in y over the change in x, our gradient now is 4 over 3. So from there to there, it got inverted. It got swapped around. And that will always work for a perpendicular line gradient. So we know now already that our equation will be y 4 over 3x. The next thing to find is the plus c, as our line was not correct, because it goes through these points here, 12 or -7, and that doesn't fit on the graph. So let's write what we have. We got y equals 4 over 3x plus c. That's what we have to figure out now. But we have y and x value in this coordinate that they've given us. That's a x, that's a y. So we can simply substitute those values into our equation. So y is -7, x is 12, and then calculate it. 4/3 times 12, 16. So we need to subtract the 16 from the -7, and that gives us a c value of -23. Question 17, probability. 3 blue buttons, 8 white buttons, 5 red buttons. That gives us a total of 16 buttons. Now we're picking 2 buttons at random from the bag without replacement. That's very important. We don't put them back after we've taken them out. Okay, so we work out the probability of getting 2, both red or both white. So let's start with the probability of getting a red and a red. So I pick a red one, then I pick another red. So what is the probability of picking a red one the first time? There are 16 buttons, and there is 5 red ones. Okay, and then remember here we're doing the AND rule now. AND rule always being multiply. This AND that has to happen, multiply. We have to pick another red one. Now remember there's only 15 buttons left because we've taken a red one out, and there's only 4 red ones left because we've taken a red one out. Okay, so that will give us the probability of picking a red and a red. Okay, slot that into your calculator. Save time, don't break your head over it, don't try anything fancy. Gives me 1/12. Right, then the next one, the probability of getting a white and a white. So probability white and white. Okay, let's see. Right, this is a different event. Okay, this is or this can happen. Right, so again, we start from the beginning. There's 16 buttons. Probability of getting a white one is 8. Okay, half of them are white. Then, and the following has to happen. After 15 buttons there are left, there's now 7 whites left. Right, let's throw that into our calculator. And we get 7/30. Alright, so remember these are two events. They're not both going to happen. It's the one or the other. So we're doing the OR rule, which means add. We need to add this together. 1/12 plus 7/30. And that will give us our final answer. 19/60. If you want to write it as a percentage decimal, that is fine. Question 18. In the examiner's report says this is one of the questions where most students lost a mark. One of the hardest questions in the paper. Let's go through this slowly. See, it's not that hard. You can do it. S is a point on PQ such that PS to SQ is 4 to 5. So that piece of information means this has a ratio of 4 to 5. What we need to do now is say, right, PQ has been divided into 9 parts, of which PS is 4, SQ is 5. So it means PS is 4/9 of that line and SQ is 5/9. That is important. Right. Then it says find OS in terms of A and B in the simplest form. So let's draw OS. Let's draw OS in there. Okay, important to put the arrow in. Okay, so we need to find OS. It's important now to follow a route that we have. So we can either go OP, and then PS, or we can go OQ and then QS. Okay, either one will work, whichever you prefer. But what we noticed immediately is we don't have PQ. We don't have PQ in terms of A and B. So first, we're going to have to work that out. PQ. I mean, we can do QP, but let's keep it alphabetically. All right, so PQ is this route here. Okay, going from P to O, we're following A, but we're going in the opposite direction. So that means PO is a negative A. To PO, then we add OQ, which is simply B. Okay, so that means that PQ equals PO plus OQ, or rather PQ equals negative A plus B, or if we like to write it more prettily, B minus A, same thing. Okay, just note here that I've written down the route in terms of the capital letters here. You can get a mark for this, so it's important to write this down to show that you know which route to follow. Okay, so now that we've got PQ, which is B minus A, okay, or rather, if we want to use the piece of information given to us before, PS is 4/9 of B minus A, and SQ, remember we're going in this direction, is 5/9 of B minus A. So we got those parts of the line. Now things have become a bit easier, right? We just need to pick a route of getting from O to S. I'm going to pick this route simply because A is first in the alphabet. So that means OS equals OP plus PS, where OP equals A And PS now we can clearly see is 4/9 of B minus A. That's it. We got the answer, but we have to put it in the simplest form. So let's expand those brackets. We'll do it over here. A plus 4/9 B minus 4/9 A. Okay. Imagine this A is 1A. 1 minus 4/9 of course is 5/9. So that will be 5/9 A plus 4/9 B. And that is our final correct answer. Let's write it on the line. 5/9 A. Don't leave anything out and lose a mark at the last moment. Plus 4/9 B. And you've done it. Question 19, they ask us to graph the y equals tan x graph. If you can remember what it looks like and just do it straight away, brilliant. But if for any reason you forgotten shape of the graph or you're not sure, we can always check where it crosses the x-axis and what its shape is like by slotting values into a calculator. So if we want to know where it crosses the y-axis, we just put in tan 0, and that we get 0, so we know the graph starts there at 0. Let's see what happens at 90 degrees. Slot it tan 90, and you get the error message. Okay, that means this graph never crosses 90 degrees. So it means it's an asymptote. So when we're going to draw this graph, make sure we don't cross 90 degrees at all. We can put a few dots in there to make sure we don't make that mistake. Okay, so what does it look like between 0 and 90? Let's plot some values. Let's look halfway. Tan 45 is 1, so let's guess 1 is over there. Let's see, we've got like 1 degree. We get a very small value. If we go close to 90, we do tan 89. We get a very big value. So by now you must have remembered that a tan graph looks something like this. Okay, where it approaches the asymptote but never touches. So don't cross that 90 degree line. Use a pencil, so if it's ugly, you're not happy with what you've done, just rub it out and do it again to get that smooth upgoing curve. Okay, and that's it. If you remember now what it looks like, you can do it in. You can always check any value to make sure you don't make any mistakes. It's going to go through 0 at 180, at 270. We get another error message, so there's another asymptote. Okay, it's not going to cross there. Let's see, for example, tan 100 is negative, so we know between 90 and 180 is negative. In the end, it's going to look something like this, if you remember correctly. Okay, and again here. Right, there's our graph. Make sure it looks nice. Don't curve back like this. That's incorrect. Don't give them any reason not to give you your marks. So you always use a pencil and a ruler. Rub it out. Make sure it looks perfect. Have to be honest, it's quite difficult. That's better. Okay, next one then. When you're happy with your graph, we do question 19b. We need to solve that equation. So 5 tan x equals 1. First thing we're going to do, move that 5, get rid of it. So we divide both sides by 5. That will give us tan x equals 1/5 or 0.2. Okay, next thing we need to move the tan. So of course we want to know what x is. That means we got tan to the power of -1 on the opposite side. And let's slot that into our calculator. Shift tan 1/5. And we get 11.3. So that means x equals 11.3. So what does that actually mean? Let's have a look. All right. Remember, the x is an angle, so that's degrees. So if we go here, 11.3 would be somewhere over here, rough estimate. So we go up, we meet the graph, we go across, that will be 1/5 or 0.2. Okay, is over there. There is another answer. So as you can see, we need to give two values there. So that means if we would go across, follow 0.2, we will cross the graph again over here. Okay, so there's the second answer. Will be there somewhere just above 180. Okay, this graph is symmetrical. So it means this distance here between 0 degrees and 11.3 is going to be the same distance between here 180 and where our answer lies. So to find the other angle, all we need to do is do 180 plus 11.3 gives us 191.3. Okay, we're going to calculate it. There's the full answer. Okay, so we got our two answers, 11.3 degrees, 191.3. Remember, we're rounding all angle answers to one decimal place, not to three significant figures. We can check if that's right by simply slotting in ton. Now putting in my previous answer, which is 191.3 equal, and I get 1/5. I know my answer is correct. You've done it. Question 20, the last one on the paper. And always be aware that there could be a trap. Right, the distance between two towns is 600 kilometers, correct to the nearest 10 kilometers. So when you see it correct to the nearest 10 kilometers, it means 600 has been rounded. We need to find the upper and the lower bound. So let's start with that, right? 600 kilometers. We want to find the lower bound and the upper bound. Okay, now we take this 10 kilometers divided by 2, we get 5, and that's what we need to add and subtract to get the lower and the upper bound. So 600 minus 5 gives us 595 kilometers. That will be the lower bound, and of course the upper bound will be 605 kilometers. Right. Next one, then we got 8 hours 40 minutes, correct to the nearest 10 minutes. Again, we take this 10 minutes, we divide it by 2, we're going to add and subtract 5 minutes to that time. So for 8 hours 40 minutes, the lower bound would be 8 hours subtract 5 minutes, 35 minutes. Okay, and the upper bound will be 8 hours 45 minutes. Okay, now we need to calculate the lower bound for the average speed of the car. So we are working with speed here. If you can't remember, draw your little triangle. Okay, speed is kilometers per hour, kilometers being distance, and hours being time. So what we're going to have to do is we're going to have to divide distance by time. Okay. First thing is working with hours and minutes. That will not be possible, okay, to slot into a calculator like that. So we need to change this to a decimal value. So remember, 8 hours 35 minutes is the same as 8 hours and 35 minutes out of 60 minutes. Okay, now 35 out of 60 is 0.83. So 8.583 recurring hours. And the same with the other one. 8 hours 45 minutes is 8.45 over 60. So we got 45 out of 60 minutes, of course. You know it is 3/4 of an hour. So that will be 8.75 hours. Okay, don't get confused between minutes and decimal values. They're not the same. So I've done all of these, okay, because working out the lower bound is not as simple as taking the lowest values here, because we are going to be dividing. We want to get the smallest possible answer. Okay, let me show you what I mean. If we were to take the lower values, okay, 590 5 kilometers, and the lowest, shortest, quickest time it could possibly be, see, kilometers per hour. Look what we will get. Okay, 595 divided by 8.583 recurring. Yeah, we'll get 69.32. Average speed is kilometers per hour. Okay. Not sure you can see that. Okay. That is not going to be a lowest possible answer, because to get the lowest possible answer, we need to take the smallest possible distance. No. Yes. See, I'm also confused. And divide it by the biggest possible time. Let's see what that gives us. Okay. So I'm going to take 595 divided by 8.75 equals 68 kilometers per hour. You see, that is a lower answer. And this is where most students make the mistake. They think using the lowest values will give you the smallest possible answer, but in fact not. Think carefully, yes? If you divide by the biggest possible value, then you will get the smallest possible answer. And that's why the answer is 68 kilometers per hour. If you're confused, use all your bounds and work out all the other values. Take the upper bound, divide by the upper bound divided by the lower bound, and see which answer is the smallest, and that's the one you want to slot into your calculator. And you've done it. Well done. And yes, I know I'm upside down, but I hope you found this useful. Like and subscribe. See you again soon.